This is Laura Duncan from CSMS. Today we're going to be solving quadratics by factoring again. So first we begin with the quadratic equation. We want to make this quadratic equation equal to 0 so that we can find its solutions or zeros. And we do that by performing the opposite operation, so that these will cancel out and leave the solution equal to 0. So our equation now reads s squared minus 18s plus 81. Notice that that is a perfect square. So in that case, we'll have s minus 9 equals 0, and then it's the same equation. So in this case, there is only one solution, 1, 0. And so the solution is s equals 9. Let's look at number 2. In number 2, we're going to isolate one side so that this is equal to 0, so that we can find our zeros or solutions. Notice this is a difference of perfect squares. So we'll have the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. Now that we have it factored, we'll take each factor and set it equal to 0 so that we can find the solution. So go ahead and pause the video there as you solve both equations. Now we have the two solutions for negative 2, x equals 5/4 and x equals negative 5/4. Try number 3 on your own. Pause the video here, please. Now we can take a look at number 3. So if you're having trouble factoring, remember that you can go back to the box method. So we factored it, and we've ended up with two solutions, b equals negative 1/2 and b equals 3/4. Let's take a look at number 4. On number 4, the equation is already equal to 0. However, as we look at this, do you see how 24 and 8 have something in common? So they have an 8 in common. So I'm going to, they also have a GCF of x, so the GCF is 8x. Let's first factor out the GCF, the greatest common factor, and then we're left with 3x minus 1. Now we'll put each factor equal to 0. So 8x equals 0 and 3x minus 1 equals 0. So we'll divide by 8 on each side to isolate the x value. So one solution is x equals 0. And then we'll come to the second equation and isolate the variable and get a solution of x equals 1/3. So those are our two solutions. We found the GCF first, and then from there we solved it. So when we're solving these equations, I want you to be sure that you're looking for the GCF first. From now on, that is the new part of this lesson. Also, we need to isolate on number 5 And we're going to make sure that the n squared coefficient is positive for our purposes today. Now, as we go forward and rewrite this, we're going to have a positive 20 n squared. Let's rearrange it so that n squared is first, then the n, and then the constant. Now, please first look for the GCF in each problem. The greatest common factor here is 2. So we'll have 10 n squared minus 3n minus 1 equals 0. Now you'll be factoring that. Please pause here while I give you a chance to factor that. Now that we've factored, it appears that we have 3 factors that will be equal to 0. However, when we look at this first factor of 2, 2 is not equal to 0. So that will not be used. Since it's not true, we are going to throw it out. However, we'll take the other 2 factors, 5n plus 1, set that equal to 0, and 2n minus 1, set that equal to 0. Please pause the video as you solve for n now. Now that you've solved, you have 2 solutions, n equals negative 1/5 and n equals 1/2. Please turn your attention to number 6. First, is there a GCF? If there's a GCF, we'll first take that GCF and factor it out. So we're left with 4r squared minus 1. Now that's a difference of perfect squares. So we'll have that factor of 3, and then we'll take the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. And again, it appears that we have 3 factors, but since 3 is not equal to 0, we throw that factor out. So 2r minus 1 will be equal to 0, and 2r plus 1 will be set equal to 0. Please pause here while you solve. Now we have our 2 solutions, r equals 1/2 and r equals negative 1/2. Now we'll turn our attention to some application problems. If a number, let's call that number n, is added to its square, the square of n is n squared, the result is 30. Find the number. So you can see that we have a quadratic equation. The first thing that we're going to do is set it equal to 0 by doing the opposite on each side. I'm going to rearrange this so that our n squared here is first. So n squared plus n minus 30 equals 0. Now we can factor it. Because it's a coefficient of 1 on the n squared, that should make our job easier. So we know that 6 times 5 is 30. The 6 will be positive and the 5 will be negative to get a coefficient of 1. Now we'll set each of these factors equal to 0 and solve. Please pause here while you solve the equations. So it appears that we have 2 numbers that will satisfy this solution. N equals negative 6 and n equals 5. If you doubt the solutions, simply substitute it back into the formula that you've created and make sure that both solutions will come up with a true answer. In example 8, it's a review question. Find 2 consecutive even integers whose product is 168. Well, remember that we're going to start with our let statement. let x equal the first number. If it's an even integer, to get to my next integer, I will add 2. So x plus 2 will equal our second number. Now it says find two consecutive even integers whose product is 168. That means that we are multiplying. We're multiplying x times x plus 2, and their product is 168. Now this is what we've been doing. First we will distribute the x to each term. We can see that this is a quadratic equation, so we'll subtract 168 from both sides so that we can set this quadratic equation equal to 0 to solve for the zeros. Now please pause the video while you factor this equation. Now the factors are x plus 14 and x minus 12. We'll take each of those factors and set them equal to 0. Please pause the video here as you solve the equations. So finally, we have that the numbers are 12 and 14. Those are the two consecutive even integers whose product is 168. Example 9. Find the dimensions of a rectangle whose perimeter is 48 and whose area is 143. So let's review perimeter. To find perimeter, we would have 2 times the length plus 2 times the width. To find area, we would have length times width. We use that information that's given in the problem. The perimeter is 48, so we have the equation 48 equals 2 times length plus 2 times width. And the area is 143. That would be 143 equals length times width. What we have here is a system of equations. So if we have a system of equations, we can solve this by using one of 3 methods. This time, let's choose to use substitution. Since we're wanting both the length and the width, it doesn't matter which one we solve for. So let's go ahead and solve for length. So I'm going to isolate the length by subtracting 2w from each side. And then I'll divide by 2 for each term to isolate the length. Now that I know my length is equal to 24 minus w, I will simply substitute that into my other equation. Now, I will distribute the w, so 143 equals 24w minus w squared. This is a quadratic equation, so I'm going to get everything on one side by doing the opposite so that I can set this equal to 0. Now you have an opportunity to factor this equation. So please pause here as you factor. Now that you've factored, set each one of the factors equal to 0. And we have the width equals 11 and the width equals 13. But really, what we're looking at is we're looking at the dimensions. So the dimensions of this rectangle are 11 and 13 units. That gives us the length and the width. This concludes your lesson for today.